Let's say we have more than one event going on. A compound event is an event that is formed by combining two or more events. One type of compound event is in the form A or B. The event A or B occurs whenever A occurs, B occurs, or A and B both occur. Probabilities of events in the form A or B are computed using the addition rule. So the general addition rule states that if I'm finding the probability of A or B, I'm going to take the probability of A plus the probability of B and subtract out the probability of A and B, because this is where we'd have an overlap, where maybe something was in A and B, and we have to subtract that out. So let's see where that would fall in this one. We have 1,000 adults were asked whether they favor a law that would provide support for higher education. In addition, each person was classified as likely to vote or not likely to vote based on whether they voted in the last election. What is the probability that a randomly selected adult is likely to vote or favors the law? So we're looking for those that are likely to vote or favors the law. So we're trying to find the probability of likely to vote or favors. So what we're going to do is we're going to take the probability that it's likely to vote. I'm just going to call it likely, plus the probability that they favor the law, and subtract out the probability that it's both, that they're likely to vote and they favor the law. So the probability that they're likely to vote, well, I would need to take this whole group, right? Likely to vote would be this whole row. So I would add those together. So 372 plus 262 plus 87, that leaves me 721 people that were likely to vote out of the 1,000. Plus, the people that favored the law was this group. If I add those together, I get 523 out of 1,000. But notice this group right here. They were likely to vote and they favored the law. We've counted them twice. I counted them in that circle and in that circle. So I need to subtract that group. So notice that this is nice because they all have the same denominator. I could add those numerators and subtract 372. And so if I was using this calculator, I'm going to do 721. I wish this didn't have a glare on it. Divided by 1,000 plus 523 divided by 1,000. So this is one of the nice things about using that NumWorks app. We can actually write them in as fractions. You can do it on the TI too. But the nice thing about this app is when I get done with the fractions and press enter, it gives me the reduced fraction, which is pretty cool. And it also gives me the decimal. So that equals 109 out of 125. And it gives me the decimal also, which is 0.872. And that's our probability. Now, some events are mutually exclusive. And mutually exclusive events, if they're mutually exclusive, it is impossible for both events to occur at the same time. So a die is rolled. Event A is that the die comes up with the 3, and event B is that the die comes up with that should say even number. Can you roll a 3 and an even number at the same time in one roll? No, these would be mutually exclusive. Now let's say a fair coin is tossed twice. Event A is that one of the tosses is heads, and event B is that one of the tosses is tails. Is that a possibility? Yes, these are not mutually exclusive. Because I could have a head on the first one and a tail on the second one, or a tail on the first one and a head on the second one. There's 2 different ways that can happen. And for thinking about these, if we're thinking about like Venn diagrams, so mutually exclusive would mean that event A is over here and event B is over here, and there's no overlap. That's mutually exclusive. If they're not mutually exclusive, you'd have A and B, and they have this overlap where they could both happen. This is the not mutually exclusive. Now, what's nice about this is if there's no way for them to occur at the same time, then when we're talking about that addition rule, where we take the probability of A plus the probability of B, and we subtract the probability of A and B. Well, if they can't occur at the same time, then this is 0. So we would just add the 2 other probabilities, and we don't have to worry about an overlap, which means it's super nice. So we know the events are mutually exclusive. That makes things a whole bunch easier. Let's look at an example. In a recent year of the Olympic Games, a total of 11,544 athletes participated. Of these, 554 represented the United States, 614 represented Canada, and 125 represented Mexico. What is the probability that an Olympic athlete chosen at random represents the US or Canada? Well, let's think about that. Could we have somebody competing for both? No. So these are mutually exclusive. So if I'm finding the probability of somebody from the US or Canada, that's just going to be the probability of from being the US plus the probability of being in Canada, from Canada, or representing Canada, should be a better word. There's not an overlap. They can't represent both. So I would have 554 out of the 11,544 plus, let's see, 614 out of, that seems really high for Canada, but I guess that's right. Okay, out of the 11,544. And so we would add those together, which if I just added those numerators, this one's a pretty fast one. And the decimal would be 0.0, whoops, that's not right. Where did I mess up? Oh gosh, I messed up. I was looking at another example. 554 divided by 11,544 plus, whoops, got to be careful. You got to come out of the fraction. Plus 614 divided by 11,544. And it gives it to me in the reduced form, which is kind of nice. 146 over 1443. That's 0.1012. Now, there's another thing we want to talk about, and it's the rule of complements. Let's say there's a 60% chance of rain today. Then that means there's a 40% chance that it will not rain. Rain and no rain are complement events. If A is any event, the complement of A is the event that A does not occur. And we denote it with an A with a little C. Some textbooks do an A with a little dash instead of a C. Both of those mean the same thing. So let's say 200 students were enrolled in statistics class. Find the complements of the following events. Exactly 50 of them are business majors. Well, what would be the complement of that? Exactly 50 of them are business majors. So the complement of that is that the number of business majors is not 50. It could be less, it could be more, it's just not 50. More than 50 of them are business majors. Well, the complement would be that 50 or fewer are business majors. At least 50 of them are business majors. Now be careful with that wording. At least 50 are business majors. So that means 50 or higher. So the opposite of that would be that fewer than 50 are business majors. Oops, can't spell business. All right, now the rule of complements comes in that if we want to find the probability of the complement of an event, well, it's just going to be 1 minus the probability of the event. Sort of like that chance of rain. 60% chance of rain, 40% it's not raining. So according to the Wall Street Journal, 40% of cars sold in a recent year were small cars. What is the probability that a randomly chosen car sold in that year is not a small car? So we want the probability of being not small. That's going to be 1 minus the probability of being small. So 1 minus 0.40, because 40% would be 0.40. That gives me 0.60 or 60%.